First up, we've got notes that you will have to read. And this is a rhetorical synthesis question. The reason I say notes that you will have to read is that the prevailing strategy for these has been to completely skip the notes. And I would argue that 9 out of 10 times, you're still going to be able to skip the notes. However, you might need to read them just a little bit. Let me show you what I mean. So let's start going through this. Normally, we would want to skip the notes and just focus on the goal. So what is the goal? The goal is to describe this exhibition that was curated in 2018. Now, normally I would say, let's go through and eliminate any answer choices that don't match this goal, right? But when we glance at our answer choices, the only time we see 2018 is choice C. And all it says is that in 2018 and 2020, this guy curated exhibitions. It doesn't say which exhibitions. So the issue is we don't know which exhibition was curated in 2018. So we don't need to read all the notes, but we do need to quickly figure out what that exhibition was before we move on to our elimination step. So eyeballing the notes here, I see 2018, so I'm just going to read this note. She curated Whitney's 2018 exhibition, Pacha, Lakta, Wash. I'm not even going to try to read the rest of this, but this is what I'm looking for, right? We'll call it PLW. PLW. So now I'm looking to describe PLW. Choice A, held at the Whitney Museum. The exhibition doesn't mention PLW, so I'm going to get rid of it. B, PLW, an exhibition at the Whitney Museum featured works by 7 emerging artists. Okay, it describes PLW, I'll keep it. C, I already went over that. It doesn't describe anything. It just says that 2 exhibitions were created. D, doesn't mention PLW, so pretty quickly my answer is B. So again, you might need to look at the notes just a little bit, but you probably won't need to read all of them, and you should still definitely start with the goal. That way you know what you're looking for in the notes. Next up, we've got reading comprehension for fiction passages. Starting with the question, we see that this is a central idea question. It's a main idea question. And for main idea, a lot of the time you will need to read the whole passage, but sometimes you'll find the main idea in the beginning or end of the passage, which can help if you're running low on time. Anyway, let's take a look. Following text is from a 1902 novel, and I want to take note of 1902 here because if it's over 100 years old, I might run into some weird vocabulary, so that's something to look out for. And then as far as context goes, 5 young siblings have just moved in with their parents from London to a house in the countryside that they call the White House. Okay, it was not a pretty house at all. It was quite ordinary, and Mother thought it was rather inconvenient and was quite annoyed at there being no shelves to speak of and hardly a cupboard in the place. Father used to say that the ironwork on the roof and copying was like an architect's nightmare, but the house was deep in the country with no other house in sight, and the children had been in London for 2 years without so much as once going to the seaside even for a day by an excursion train, and so the White House seemed to them a sort of fairy palace set down in an earthly paradise. So especially with fiction, I would say you probably need to read the entire thing because if it's nonfiction, like I was saying, you'll find the main idea sometimes at the beginning or end. But with fiction, it's more about reading the whole thing and sort of asking yourself, like, what happened or what did you just learn, right? So what I just learned is that the parents don't like this house. We have 2 examples how Mother was complaining about all this stuff, and then Father was complaining about all this different stuff. So that's like the first half, right? But then the second half, we get the children's perspective, which is that it is a sort of fairy palace, which I would argue is definitely a positive thing, right? Think about a fairy palace. It's beautiful. So after you figure out what your main idea is, I recommend coming up with a prediction, which is basically putting that main idea into your own words. So for me, it would be something along the lines of parents hate the house, kids dig it. All right, so that's my prediction. And then the last step is to eliminate answers that don't match my prediction. Choice A, Although their parents believe the house has several drawbacks, they hate it. The children are enchanted by it. They dig it. So that seems like a pretty darn good answer. I'd probably choose it and be done with it. But just to show you the elimination step, let's get rid of the other answers to be safe. B, the children don't like the house as much as their parents do. That's the opposite of my prediction. Each member admires a different characteristic. No, the parents don't admire anything. The house is beautiful and well built. It says it was really not pretty at all, and that's like the narrator, so this is just untrue. Pretty easily we can go with choice A here. Next up, we've got words you don't know. And what I want to talk about specifically is at the beginning of the English sections, you've obviously got words in context. You're going to come across some words that you don't know, and I'd like to teach you when you would actually end up choosing one of those unknown words as an answer, all right? So first, let's talk about strategy for these. I recommend a quick 3-step strategy, the first step being to analyze the text. And as you're analyzing, you are looking for context. You're trying to figure out what part of the passage is going to help me fill in the blank. So here we have some foraging models predict that the distance bees travel when foraging will decline as floral density increases. So basically the distance traveled will decrease as floral density goes up. But biologists Shailene Jha and Claire Kremen showed that bees' behavior is inconsistent with this prediction if flowers in dense patch areas are blank. Then there's a colon. So this colon is telling me everything I need to know as far as context goes, because colons are really good for giving examples among a couple of other things. So I know that whatever comes after the colon is going to be an example of what was just before the colon. So basically, this should be an example of my answer. So this is the context that I'm really going to focus on. Bees will forage beyond patches of low species richness to acquire multiple resource types. So my example is they will go farther past low species richness. Low species richness would mean there are not as many types of species. So this would be like less variety. And to acquire multiple resource types, basically to a place where there's more variety. So as far as filling in the blank goes, step 2 is to come up with some sort of a prediction. All right, so it says they will do this if flowers in dense patches are blank. Basically, if they have less variety. And here's a little tip for you. You don't need your prediction to be one word. It could be a phrase. So I'm going to make it a phrase. I'm going to say, if flowers in dense patches are all the same kind, right? All the same kind is basically no variety. So that is my prediction. The last step is to eliminate answer choices that don't match your prediction. Let's say I look at depleted. I know depleted. Depleted is when something is like empty, right? So all the same kind, that doesn't mean empty. That doesn't mean that we've finished everything. So A is out. B, I don't know how to pronounce that. I don't know what that means. So I'm going to skip to choice C, right? Immature. Immature means not mature. Definitely doesn't mean all the same kind, so I'll get rid of C. And then D, dispersed. Dispersed means spread out. It doesn't mean all the same kind. So if I didn't know what homogeneous meant, but I confidently deleted 3 answers, that is the only time I should choose the answer I don't know. And yes, homogeneous literally means all the same kind. Homo meaning same, and then genius referring to like species, basically, like your different genus types. Next is going to be sentence boundaries questions involving though or however. And I am pointing these out specifically because they could be very tricky. The reason is that though or however can either end a sentence or an independent clause, or start a sentence or independent clause. Let me just give you a really simple example first. So my example is going to be, though I don't like cheese, I do love pizza. See how I'm starting a sentence with though. I could also say, I love pizza. I don't like cheese though. All right. So you're seeing how you could start or end. And then similarly, I could say, I don't like cheese. However, I do love pizza. Here, we're starting an independent clause with however, and I could definitely turn this into a period, but normally you're going to see a semicolon on the SAT because they like to mess with you. So that is, again, beginning a sentence or beginning an independent clause with however, and we can kind of do the same thing. I don't like cheese. We'll do another semicolon. We'll say, I do love pizza, however. So again, the reason that these are tricky is that you can begin or end a sentence with however or though. All right. So let's now talk about this particular question and how to deal with it. It is sentence boundaries, which means we only have to focus on the sentence with the blank space. So I'm going to ignore this to start, and then I'm going to read through and kind of get a feel for how things sound. Nakalembe doesn't just compile the blank though. She also shares her findings with African farmers. And then I see a comma and an ing word, which means this is all going to be non-essential information at the end of the sentence. So I can really just focus right here. Nakalembe doesn't just compile the information though. She also shares her findings with African farmers. Just from reading this one out loud, I can tell that my answer is going to be choice A, because even though I could have an independent clause that ends after information, like choice C, for example, the logic is that she doesn't just compile the information, she also shares her findings. So in order to have that logical contrast, we need to end the first independent clause with though. If we started the second independent clause with though, now all of a sudden we're contrasting her sharing her findings with this part that I said we don't need to read. Now, obviously, if you weren't understanding what was going on, you might want to actually read it. So it says enabling them to make data-driven decisions. Sharing findings and enabling them to make data-driven decisions, those two things don't contrast. It's just expanding on what sharing the findings does. We would also notice that if we tried to start this with though, we don't have an independent clause after the comma, which we would need if we started our sentence with though. So a couple issues there. So again, the answer is choice A. I just explained why choice C doesn't work. And then as far as B and D go, B is a comma splice because we do need to have a period or a semicolon here, so that wouldn't work. And then D is just right out because like we have the comma splice, but we're also missing the comma that we need before though. So lots of issues with D. And my answer is going to be choice A. So the two steps you want to take for these types of questions are figure out where your independent clauses are. That alone would have gotten us our answer, but also think about the logic. Which two things are you trying to contrast? All right, next up, we've got verb-based questions that involve tenses or even infinitives. And here you can see that we do indeed have an infinitive to reign. And we've got multiple versions of tenses with having reigned, reigning, reign. So let's talk about dealing with this. First of all, I like to simplify as much as possible. I'm going to just start with this main question, and if I end up needing context, I'll read the first sentence. But let's see here. We've got these spherical bits of glass form when asteroids collide with the planet, ejecting bits of molten rock into the atmosphere that... And then we've got this non-essential information, so I'm going to ignore that. Ejecting bits of molten rock into the atmosphere that blank back onto Mars's surface. Now, honestly, a lot of the time, just getting rid of non-essential information can make things a lot clearer. So let's just read the answer choices out loud to start. Ejecting bits of molten rock into the atmosphere that terrain back onto Mars's surface. So that should be a red flag, right? That doesn't sound right because we want to say bits of molten rock that something, bits of molten rock that do this thing. And you hear me saying the word do, which should just be a simple present tense verb. What's our simple present tense verb? Rain. Bits of molten rock that rain. So just by reading it out loud and sort of using the word do, I knew that I needed that simple present tense rain, but let's quickly eliminate the other ones. I already read A out loud, and it was clear that we didn't need an infinitive. Ejecting bits of molten rock that raining. So we would need that are raining or that were raining. We're missing that helping verb, so we have to get rid of B. Now C could kind of work depending on how things ended. We could say something like ejecting bits of molten rock that having rained down, da-da-da-da-da-da, and then go on from there. But we don't have anything that goes on from there. This is the end of the sentence, so C would also not work. Standards questions like the one we just went over make up around a quarter of the English section. And if you know all the rules, they're pretty quick and easy. If you use the link in the description of this video, you're going to get 20% off my new punctuation and grammar course, which is designed to get you 100% in standard English conventions. The course includes over 100 practice questions you're not going to find on College Board or anywhere else, and it only takes around 4 hours to complete. Just click that link in the description to get 20% off. Moving into the math section, we've got interpreting quadratic equations. And when you're working on these types of questions, first of all, start with the main question so you know what you're looking for. Which of the following is the best interpretation of the vertex, all right? So we know from the start we're focusing on the vertex. Now let's also talk about what happens with a quadratic. So if you imagine a quadratic on a graph, typically you're going to get something like this, where you've got like either a smiley face or a sad face, right? You have a parabola. In the context of a word problem, it's going to be a little bit different. You're usually going to be throwing something. So imagine like you're tossing a ball up into the air, and maybe you're standing on a ladder, right? So it starts off up here, maybe the ground is down here, and then you throw a ball into the air and get that quadratic parabola curve. In the case of a positive parabola, which is usually going to look something like this in the context of a real problem, you basically have the scenario that's described here. You have something maybe like hanging from a rope, and then it swings in that parabola shape. So with that in mind, the vertex is going to be either the height, the maximum height if you're throwing something, or the minimum height if you're swinging something. In this case, we know that we're swinging something, so basically we're looking for the minimum height if we're thinking about the vertex. Choice A says the ball's minimum height, so we would keep that one. Choice B says the ball's minimum height, so we would keep that one. C and D just say height when it started moving, so that is not what we're looking for. And then we just have to figure out, was the height 3 or was the height 7? Well, this is actually in vertex form, so a little refresher. Vertex form is going to be y equals a times x minus h squared plus k. And your vertex in vertex form is hk. Hk is the vertex, where h is your x value and k is your y value, all right? Now, the one thing you have to remember is it's minus h in the equation. So if your h is a positive number, it becomes negative, and if it's a negative number, it becomes positive. So in this case, our vertex would be 7, 3, right? So our vertex is 7, 3. And height is rise, right? Up and down is your y, so that would be height. And then left and right would be your x. So since your y value is 3, your answer would be 3 inches above the ground, choice A. And while we're on the topic of interpreting things, we've got another interpreting question, but this one is for an exponential equation. And More often than not, and this is the reason this is a prediction that this is going to show up on your next SAT, is that more often than not, they want you to interpret the y-intercept or figure out the y-intercept of an exponential equation. So let's just talk about the exponential equation in general to start. Basically, you're going to have your total value, and then you're going to have your initial value. You're going to have some sort of percent increase or decrease, and then you're going to have your time, all right? And a little shortcut that we should know is if you're looking for the y-intercept, all you have to do is make x 0. So what is x? Well, remember your function on the left side is always going to be your y value, and it is function of t. So t is standing in for x. That means all you have to do is turn t into 0 to get your y-intercept. And then any time to the 0th power is 1. So basically, the y-intercept of any exponential function is going to be when you're not increasing or decreasing by any percent. It's literally just where you started from. It's your initial value, right? So in this case, it would be 8,000 times 1. So it's just 8,000. So what we could do is get rid of any answers that don't have 8,000. So A and C would be out. And then we want our starting point, basically, right? So we do want to read just a little bit of the actual problem to find out what our starting point should look like. So if we eyeball it here, it says T represents the number of years since the end of 1998. Since the end of 1998. That means our starting point should actually be the end of 1998, which is exactly what we see in choice D. So our answer is choice D. Next up, we've got questions involving interest. And for these, we really just need to know, what is interest? Is it going to be something that increases or decreases? The most common context for this is going to be like if you get a loan. So let's pretend you buy a new car and you have to make payments on that car. Now, the car is originally like $20,000 and you're going to be paying that back for 5 years, but you're actually going to end up paying more than it was originally worth because you have to pay interest. So interest is going to be an increase in your original price. As long as you can remember interest is an increase, you should be good. Now, of course, you're also going to need to understand how percentages work. But let's take a look at the situation here. It is asking what is true about the investments, and all we need is right here in this chart. So let's just go through and start eliminating answers that are not true. So A says account A always earns more money per year than account B. So let's compare what happens here. Account A started with $500. But it's not talking about where we started with. It's saying what we earn every year. So this balance increase is what we are earning, right? So 6% annual interest, well, annual means yearly, right? So every year we're going to be getting 6% of whatever we have. So if we just look at that first year, starting with 500, to get 6% of 500, we just multiply 500 times 0.06. Because remember, 1 is like 100%, 1.00. So whenever you're thinking about percent, just think about that. 1.00 is 100, so 6 would be 0.06. You can obviously just throw that into Desmos, and that ends up being 30. If we look at account B, it's a lot more straightforward. It's just $25 a year. That's it. Well, $25 a year, 30 is more than account B. And if you think about the next year, account A's 6% is just going to keep getting bigger and bigger, because the second year it's going to be 6% of 530. And then it's going to be 6% of whatever the new amount is. So yes, account A always earns more money per year than account B. And because of that, we can only have one true answer. Which of the following is true? That means only one is true. Since we've proven beyond a shadow of a doubt that choice A is true, we know that's our answer. So let's not waste any more time. We'll move on to the next question. Next is comparing measures of central tendency. It's highly likely you're going to come across a question that asks you to compare mean, median, or mode. In this example, we're comparing all three. So let's quickly define these things. The mean is going to be the average. And in order to get the average, we take our total and we divide by the number of values. Median is simply the middle number. So if we were to take all of our values and line them up from smallest to biggest, the median is the number that's exactly in the middle if you have an odd number of values. Or if it's an even number, like we have in this case, it would be the average of the two middle values. And then the mode, which is usually the easiest, is just the most common value. So like in this case, we have to just go off of frequency. So the highest frequency, because frequency is just how many of them there are, that's going to be our mode. So we already know right off the bat that the mode is 18. So if it's asking us to give the correct order of the mean, median, and mode, we really just have to quickly figure out what they are and then put them in order. So we already determined that the mode is 18. The median is also usually pretty easy to find. If you have an actual list, you can just start crossing things out from outside to inside. Like let's say I had a list of 1, 2, 3, 4, 5. It would be pretty easy to go cross off, cross off, cross off, cross off, and then you land in the middle. But if you have a larger list, or if it involves frequencies like this, there's a different trick that you can do. You take your total and you divide it in half. So in this case, 20 divided by 2. If it's an odd number, you would end up with a decimal and you round up. So like, let's say instead of 20 over 2, we had 9 over 2, right? We would end up with 4.5, and then we would round up to 5. But in this case, it's an even number, which means we're going to take our answer and we're going to average it out with the next highest number. So 10 and 11. And to be clear, I'm not saying we're going to find the average of 10 and 11. We're going to find the average of the 10th value in the list and the 11th value in the list. So if we go from smallest to biggest, we have 6 18s, 5 19s. So this is already our first 11 numbers. So the 10th and 11th number are both 19, which means our median is also going to be 19. All right, so we already know mode is 18, median is 19. Now, finally, we've got our average, which we already know the formula for. And you could put this into Desmos and just have a list, but keep in mind, it would be a list of 20 numbers. So what would be easier would be just to write it out. And I'll show you a really nice way of doing this. So basically, if we pull up Desmos, we've got 6 18s, right? So we can say 18 times 6 plus, so this is how we're going to add our values together. Rather than writing 18 6 times, we're just going to say 18 times 6 plus 19 times 5 plus 20 times 4 plus 21 times 2 plus 22 plus 23 plus 30. So then all of that is going to be divided by 20, since we have 20 in total. So then we know that our mean is 20, which is the highest value. So in order, we want mode, median, mean, which is choice A. And that's our answer. Next, we've got what I like to call percents into numbers, where they're going to give us a lot of percents. They're going to give us one number, and then we need to sort of extrapolate, all the actual numbers. So let's look at the example so I can actually show you what I'm talking about. Basically, it's giving us a chunk of percentages. It's telling us we have 15% parents. We have 45% teachers. We have 25% school and district administrators. And then the remaining 6 individuals are students. So right now, we need to figure out what percent do we have before these 6 individuals. 25 and 45 is going to be 70, plus 15 is going to be 85. So 85% is what we have before the 6 individuals, right? So we can figure out what percent the 6 individuals are. The 6 individuals are 15%. I don't know why I keep calling them individuals. They're students. So 6 is going to be equal to 0.15 of our total. Let's call our total X. So how do we get our total? Easy. Divide by 0.15. Pop that into Desmos. We got 6 divided by 0.15. 40. So now we know that our total is 40. All right. Now what it's asking us is how many more teachers were invited to join the committee than school and district administrators. Well, let's figure out what those percentages were. How many more teachers? Well, teachers were 45. School and district administrators were 25. So as far as percent goes, it was 20% more. So all we have to do is get 20% of 40. So we can jump back into Desmos real quick, and we could say 40 times 0.2 for 20%. And then our answer is 8. Without a doubt, you're going to encounter these on the SAT. They always come at the end of the English sections. Just a friendly reminder, make sure to pause the video and try and do this on your own first, but let's talk about solving these. Rhetorical synthesis questions are incredibly easy. First thing we do is we completely ignore the notes. They're going to waste our time and distract us. All we need to worry about is what is the goal? Because every one of these questions is going to be asking about accomplishing some sort of a goal. So here it says, the student wants to use a quotation to emphasize a potential problem with the Wood Wide Web theory. So emphasize a potential problem. I'm just going to try to focus on that right now, and I'm going to start going through and eliminating wrong answers. Describing trees as super cooperators. Simard first suggested that trees can exchange resources with another. All right, so there's no potential problem there, so A is out. In the decay of the Wood Wide Web, Carson and colleagues note that common mycorrhizal networks have captured. So again, it's just sort of stating a fact, doesn't emphasize a problem. After evaluating dozens of CMN studies, Carson and colleagues expressed concern that recent claims about common mycorrhizal networks are disconnected from evidence. That seems to be a problem, so I'm keeping C. D, despite the concerns expressed in the 2022 study, The Decay of the Wood Wide Web, the Wood Wide Web theory remains popular. Okay, so this is a little bit tough because they both mention concern, right? So if we're emphasizing a potential problem, we want to focus on one problem. D mentions that there were concerns, but the main idea is that the theory is still popular, whereas C, our correct answer, gives a specific concern about claims being disconnected from the evidence. So without looking at the notes, our answer is C. Go ahead and try this question on your own first. I'm not even going to say what type of question it is yet because it'll give it away. So pause the video. All right. Now this is going to be a question testing your knowledge of colons. I mean, punctuation in general, but the correct answer here is going to end up being D. Let me explain why. So colons. A couple things we need to think about. The number one thing we want to remember is they must come after an independent clause. So an independent clause is something that can stand on its own. You could think of it as, more or less a full sentence. That's the number one thing we want to think about. Once we've checked for that, there are a couple of things that they tend to do. So colons introduce lists. That's probably the most common. Colons resolve cliffhangers. colons, give an example. And these are the three most common things that you're going to see colons doing on the SAT. I'm not saying this is all that colons do, and even that first rule isn't necessarily true outside of the SAT, but within the SAT, this is what you need to remember. Let me give you an example of each, and then we'll go ahead and use this to solve this question. So a list might be something like, I love three things: dogs, cats, and pizza. Resolving a cliffhanger. So a cliffhanger is when you are left wondering what happens next. So an example of this could be something like, at that moment, something terrible happened, and then you want to resolve it. My mom ate the last slice of pizza. And then an example, I'll give you an example of an example. My cat is very cool. She wears sunglasses all the time. So as you can see, we've got a statement that my cat is very cool, and then we have an example of how my cat is very cool. So these are the three things that you want to look out for. And notice that we don't necessarily need a full sentence after the colon. So our first example, we do not have a full sentence. But you could also have a full sentence after the colon. The only thing that must be true, again, is that you have to have that full sentence or that independent clause before the colon. All right, now let's take a closer look at this question. So if we look at our blank space, we've got this really long sentence starting from in a 2016 study. And I like to simplify things as much as possible. So if we have an introductory phrase, we can get rid of that. So we've got Eastern Washington University psychologist Amani, I'm not going to try to pronounce that. We could simplify that too. We could just basically say like, this psychologist found that, and then we've got a comma among the study participants, and then we've got another comma. So whenever you have a comma sandwich like this that sort of interrupts the sentence, you can get rid of all that stuff as well. So our sentence becomes, this psychologist found that there was one personality trait that they scored particularly high on. That's a full sentence, right? And then what comes after the colon? Openness to experience. So we don't have a list, so it's not that use of colons. I would say this is a cliffhanger. It tells us there was one trait that they scored particularly high on. So the cliffhanger is, well, what's that one trait? We want to know, right? So that's why D is going to work. And in case you're curious as to why the others would not work, A, we could end with high, but then all of a sudden we have on openness to experience as its own sentence. That's not a full sentence. B, we've got a semicolon, which could separate two independent clauses, but openness to experience is not an independent clause. So B is not going to work. And then C, we have no punctuation, which is just a straight up run-on sentence. We definitely do need to separate those two independent clauses. So C is out as well. Let me give you a chance to try this one as well before I name the type of question. So pause the video, and I'm going to call this our odd verb out questions. The reason I call it that is because we can get through these very quickly by choosing the odd verb out. And let me show you what I mean. All we have to do is use he, she, or it. I'm going to go ahead and use she. And in addition to that, I'm going to use they. So either he, she, or it, and then they. And I'm going to use these words in front of my answers and decide which one is the odd verb out. So for A, we would say she hasn't been. For B, we would say she wasn't. For C, we would say she isn't. And sure enough, there's an odd verb out. We would say they aren't. So our answer is D, they aren't. It really is that simple. As long as you are dealing with a subject-verb agreement question and not a verb tense question. And you'll be able to tell, because if it's a tense question, this trick just won't work. You won't only have one odd verb out. You'll have a couple of answers that work for each. And just to kind of show you in context how this ends up working, our subject is the artistic talents. So we have a plural subject, talents, and then we would say the artistic talents aren't. Next up, we've got transition questions. Without a doubt, transition questions aren't going anywhere. You're certainly going to come across one of these questions on the SAT. And these questions are all about context. you're going to want to look specifically at the sentence before the blank space. Then you're going to look for keywords or phrases that indicate the kind of transition you're looking for. Let me show you what I mean. So we're going to go and read through this. When one looks at the dark, craggy vistas in Hitoshi Fugo's evocative photo series, one's mind might wander off to cratered surfaces of faraway planets. Then we have our blank space. It's the series title, Flying Frying Pan, that brings one back to Earth. Okay, so I'm already seeing sort of a connection here. The first sentence talks about our minds wandering off to faraway planets. The title brings us back to Earth. And hear what I just said. I said but. So I'm looking for a but. I didn't mean it like that. I'm looking for a transition word similar to but. All right? Sorry, that's not a very pretty but it'll work. Okay, let's go through, and what we'll do is we'll eliminate if we can't use one of these words in a but fashion. Consequently is a cause and effect transition. I ate 6 slices of pizza. Consequently, I was very full. So that's not going to work. Alternatively is giving an alternative, another option. So something like, we could go and have pizza tonight. Alternatively, we could get Chinese food. So B's not going to work. So ultimately, doesn't necessarily work the same way as but when we use ultimately, oftentimes it is combined with but because it is a conclusion or, what happens after all is said and done. So we could say something like, we thought about having pizza, we thought about having Chinese food, but ultimately we decided just to eat top ramen for dinner, or ultimately we decided to just eat top ramen for dinner. So here they're saying your mind might wander off into the cratered surfaces of faraway planets. So this thing is going to happen. At some point, though, you're going to come back to Earth. Ultimately, the title is going to bring you back to Earth. So my but prediction was not perfect, but it did help me find the correct answer, which is ultimately. Now, I'm feeling super confident about this, so I'm just going to circle it. If you were not, you would definitely want to go ahead and eliminate additionally as well. All right, our last type of question that you are certainly going to be encountering on your SAT are these underlined function type questions. They're pretty easy to spot because a portion of your paragraph is going to be underlined and you're really trying to figure out what the function of that underlined bit is. And when it asks about the function, it's basically asking, what does this part of the paragraph do? And for these types of questions, I do recommend reading the whole thing for context, at least until you feel like you have a good idea of your own prediction. And that leads to my second recommendation, which is to have some sort of a prediction. What do you think the underlined sentence is doing? Come up with that first, and then compare the answers to your prediction rather than relying on the answers to understand the function. All right, let's go ahead and read. Archaeological excavation of Market Street, Chinatown, a 19th century Chinese American community in San Jose, California, provided the first evidence that Asian food products were imported to the United States in the 1800s. Bones from a freshwater fish species native to South Asia. Okay, then we have a word I can't say, Hong Kong-based import-export firms likely coordinated the fish's transport from Chinese-operated fisheries in Vietnam and Malaysia to North American markets. At this point, I feel like I have sort of a prediction because basically this is a hypothesis or a guess about where the fish came from. And then let's just finish up here for context. This route reveals the often overlooked multinational dimensions of the trade networks linking Chinese diaspora communities. Okay, so we have the hypothesis, the guess where the fish came from, and then this last sentence is sort of saying like why that's important, I guess. Okay, so let's go through. A says it explains why efforts to determine the country of origin remain inconclusive. So that's not my prediction. It doesn't say anything about it being inconclusive. It provides information that helps support a claim about a discovery's significance. Okay, so a guess about where the fish came from helps support a claim about a discovery's significance that's presented in the following sentence. Okay, so I did say that that last sentence is sort of talking about why it's significant. So that actually works. It's not a perfect match with what I said, but with the last sentence context, it definitely works. So we'll keep B. It traces the steps that were taken to locate and recover the object. No, it does not. It outlines a hypothesis. Okay, I'm excited because I like hypothesis. That additional evidence discussed in the following sentence casts doubt on. Ooh, okay. So this is tough. This answer is definitely trying to tempt me because it has hypothesis, and I know that it is a hypothesis, but we know that the following sentence actually explains why it is significant rather than casting doubt on it. So D is out. Our answer has to be B. Now, you might know these as vocabulary questions. College Board officially calls them words in context, and I think that name is actually very helpful because the key to solving these is all in the context. Let me show you what I mean. Let's go ahead and read this one. Rejecting the premise that the literary magazine Ebony and Topaz should present a unified vision of Black American identity, editor Charles S. Johnson fostered his contributors' diverse perspectives by promoting their authorial autonomy. Johnson's self-effacement diverged from the editorial stances of W.E.B. Du Bois and Alan Locke, whose decisions for their publications were more blank. And before we look at our answer choices, we need to hone in on what's going on contextually and come up with a prediction of what we think should go in the blank space. Again, before we look at the answer choices. What I noticed here that's really helpful is a contrast. We have Johnson's self-effacement and Johnson's focus on diverse perspectives, which should contrast because it says diverged from, so it should contrast with Du Bois and Alan Locke, whose decisions were more blank. So if we think about offering diverse perspectives and self-effacement, that is not wanting to, promote yourself or bring attention to yourself, I'm going to come up with a prediction that these other decisions were more focused on themselves, less diverse, something along those lines. And I probably wouldn't actually write this down, but just to keep track, I'm going to say something like we'll go with like self-assured, which could be sort of an antonym for self-effacement, I guess. Now that I have a prediction based on that contrast in the context, I'm going to purge any answers. I'm going to get rid of any answers that don't match it, at least a little bit. Okay, A, proficient. That doesn't really match up with self-assured. I'm going to get rid of it. B is dogmatic. And dogmatic, you can look at the root word dogma being an established belief or doctrine. So if something is dogmatic, it claims to be true. And it often has a negative context in which there's not really any wiggle room. So somebody who's very dogmatic in the way they express their opinions might state those opinions as facts and really not be willing to accept anyone else's opinion. For example, I love cookies and cream ice cream. And if I were really dogmatic, I would say, you know what? I know a lot of you say that you like chocolate, but you're wrong. Cookies and cream ice cream is actually just the best ice cream there is. And you can hear that I was sounding quite self-assured when I said that. So this definitely works with my prediction. It's not a perfect match, but it's not something I would get rid of by any means. So I'm going to keep B. So C, ambiguous. Ambiguous is sort of like mysterious or unknown. A lot of the time it is used to describe something that's not clear. So for example, if you asked your significant other if they were mad at you and they said, I feel the same way about you that I felt yesterday, that would be ambiguous. You don't know how they feel. Are they mad at you? Are they not? It's very frustrating, but it's definitely not self-assured. So I'm going to get rid of C here. And then unpretentious, we've got un, which means not. And then we have pretentious. And pretentious, somebody who's pretentious will be very fancy and use really eloquent language and dress with high fashion to try to impress people, to sort of give this air of importance. And while a pretentious person might be self-assured, An unpretentious person would certainly not be. So D is out, and we've got our answer B. Next up, we've got science passages. And for sure, more and more of these scientific passages are showing up on the SAT, looking more like some of the stuff that you see on the ACT, actually. And the trick with these is to really just focus on supporting or refuting the conclusion or the hypothesis. So for example, this one we see we want to support the team's conclusion. Ideally, we will not have to look at the graph at all, but let's see what happens with this one. Some of the more challenging ones, you might need to look at the graph. The first thing I need to do is actually figure out what the conclusion is, which tends to be in the last sentence. And sure enough, we have the team concluded that there's evidence that the nucleobases in the meteorite formed in space and are not the result of contamination on Earth. Okay, so I want to focus on nucleobases formed in space, not Earth, basically. And I'm going to go through and start eliminating answers that do not seem to support that conclusion. A says, and I'm just going to use letters for these because part of the trick of getting through these science-based passages is to not freak out about the scientific words that you may not be familiar with. I don't know what isoguanine is or if that's even how I'm supposed to pronounce it, but I don't care. So I'm just going to call it I. I and P were detected in both meteorite samples, but not in the soil sample. Okay, so I know that soil is something that's on Earth. If we see this I and P, which I can infer are the nucleobases, and they're in the meteorite samples, but not in the soil samples, that does show that they were formed in space and not on Earth. So I'm going to keep A. B, we have A and X were detected in both meteorite samples and in the soil sample. So again, if the soil is Earth and we see these in both, that's not really showing evidence that they were not formed on Earth because they were found on Earth, right? So B is out. C says H and P were detected in both the meteorite sample 2 and in the soil sample. So again, we have meteorite and Earth. So C doesn't work because I'm looking for basically just meteorite. D says I and H were detected in the meteorite sample 1, but not in sample 2. So this one's a little tricky because it's saying it was detected in a meteorite. It wasn't detected in the other meteorite, but here it doesn't even mention the soil, so that doesn't work either. So my answer, without looking at the chart, is A. And just to clarify, if you did not make the connection that I made, that soil is of Earth, we could do a little bit more peeking through the paragraph. We could take a quick look and see that we have these 2 meteorite samples and that we have a soil sample from a landing zone in Australia. So we know that that's Earth. Next, we have important contrasting words. And these can show up in longer texts. In particular, I noticed them coming up in the central ideas and details type questions. Let me show you what I'm talking about. Anytime we're dealing with one of these questions, I do recommend starting with the main question itself so we can figure out if we're looking for a detail or if we're looking for a main idea. And this says, what can be concluded about the diminishing popularity of the portrait miniature in the 19th century? So this is an interesting one. I would say we probably want to read the whole thing for context because we're going to make some sort of a conclusion, but we're focusing specifically on that diminishing popularity. And I did say that contrasting words tend to be important. So as we read through, let's try and find any contrasting words that we come across. A common assumption among art historians is that the invention of photography in the mid-19th century displaced the painted portrait in public consciousness. All right, so we have an assumption that photography displaced the portrait. The diminishing popularity of the portrait miniature, which coincided with the rise of photography, seems to support this claim. So, more evidence for what was just said. However, there's that contrast word that I was talking about. Photography's impact on the portrait may be overstated. Although records from art exhibitions in the Netherlands from 1820 to 1892 show a decrease in the number of both full-size and miniature portraits submitted, this trend was established before the invention of photography. So I already feel like I have a conclusion based on that contrast. We have the assumption that photography is the cause of diminishing popularity, but that is, however, it might not be the case because we saw this decrease happening before photography. So that's going to be my prediction. Let's go through and eliminate some answers. A, factors other than the rise of photography may be more directly responsible. Yep, that lines up with what I said. Although portrait miniatures became less common, they were widely regarded as having more artistic merit. That has nothing to do with what I was saying. The popularity likely persisted for longer than art historians have assumed. No, it says actually that the popularity started diminishing earlier than the assumption that it was during photography's invention. As demand for the portrait miniatures decreased, portrait artists likely shifted their creative focus to photography. This is something we can infer, maybe that's true, but again, it's not what's being asked and it's not what I predicted. So D is out. Our answer is most certainly going to be A. Next up is something I like to call too many commas. And you can spot this because you've got a punctuation question, that is to say a boundaries question, and there are lots of commas in the sentence. We have a pretty short sentence here, and there's 4 commas already, right? The trick is a lot of students will look at this and think, that's too many commas. There's no way we want to add another comma, and they're going to go ahead and get rid of, D, they're going to get rid of A, and then they're going to go with either B or C because there's no way we could have that many commas, right? But that is not a logical way of thinking. As long as we're following the rules of punctuation, we could have as many commas as we want. So instead, let's read through this and figure out what's going on with the punctuation. The Tea Museum in Uncaseville, Connecticut was founded. All right, and I'm going to simplify here. So I'm just going to call this the museum. We don't need to know the name of it. We don't need to know that it's in Uncaseville, Connecticut. So we're just going to call this the museum. The museum was founded in 1931 with the goal of showcasing the culture and history of the Mohegan tribe. Then we have either and or not and. And today, nearly a century later, it is the oldest. Okay, so from reading that out loud so far, we have the museum was founded in 1931 with the goal of showcasing the culture and history of the Mohegan tribe, period, is how I'm feeling, right? That is the end of an independent clause. So if we start with today, a new sentence basically, right? We have today, nearly a century later. It's the oldest native owned and operated museum in the country, which is another full sentence. I would need a period or a semicolon. For the answers that don't include and, I don't have a period or a semicolon. If I have and, because we have 2 independent clauses separated by a coordinating conjunction, the rule is I need a comma. So C is out. My answer is A. Next up, we've got misplaced modifier questions. These are some of the trickiest types of questions out there because a lot of students just straight up don't know that this is a rule. And honestly, it's kind of a weird rule because it's not always obvious that there's a mistake. Let me give you an example of this before we look at the question. If we had the sentence, running through the field, the flowers tickled my legs. You can probably understand that I am talking about some moment in which I was running through a field and flowers were tickling my legs, right? But this actually has a misplaced modifier because the rule is our modifier, that is the action being described before the comma, running through the field, needs to be done by whatever noun or subject comes right after the comma. In this case, the first thing after the comma is the flowers. So even though we understand what's going on, according to this rule, which is honestly kind of a silly rule, the flowers were the ones running through the field. But flowers, as you may know, do not have legs, cannot run, so this is a misplaced modifier. Instead, we would want to write something along the lines of running through the field. I was tickled on my legs by flowers. So you see how this is tricky, because honestly, I think sentence number 2 here is a bit more clunky, but we have to follow that rule. At least when we're taking the SAT, we have to follow that rule of having the actual person running right after the comma. Let's use that same logic on this question here, and I definitely encourage you to try it first, but let's go ahead and look through. So our modifier is based on events that occurred when Ravenel was a city-state ruled by a king. Based on events, and I'm going to focus just on that. So whatever comes after the comma needs to be something that can be based on events. A says Ravenel Achi tells the story of Kichi Achi, a military leader. So Ravenel Achi, we get from the text that Ravenel Achi is a dance. So can a dance be based on events? It can. So I'm going to keep A. B says Kichi Achi, the military leader in the story. Kichi Achi is a person. Can a person be based on events? No. So it's not B. The military leader, another person. So it can't be C. There, existential there, can't be based on events. So D is out. And you can see by following this rule, we very quickly got the correct answer, which is going to be A. And finally, we're going to have command of evidence paragraphs that you don't actually have to read. So for these textual command of evidence questions, we really just want to figure out if we are either supporting a claim or hypothesis or refuting or undermining a claim or hypothesis. Going straight to the main question here, we see we want to undermine the claim. So ideally, we're not going to read this whole paragraph. We're just going to find the claim and get our answer based off of that. The claim tends to live close to the end. And if I start skimming through, I do indeed see Reeves claimed that the goldfish displayed robust memory capabilities by anticipating feeding times and positioning themselves in the correct tank section before food was provided. All right, so I'm focusing on these fish showing off their memory by going to certain places at certain times to anticipate food coming. So that's the claim. And again, I want to undermine that claim. So I'm looking for something that goes against that. And I'm just going to start getting rid of answers. A, environmental cues like light or changes in temperature affect goldfish behavior more often than time and location do. That actually seems to work because the memory capabilities, according to the claim, were showing up at a certain place at a certain time for feeding. So if these other factors, light or changes in temperature, affect the behavior more, that would go against that claim. So I'm going to keep A. B, the same goldfish were found to prefer brine shrimp over fish flakes. That literally has nothing to do with what we were just saying, so that's out. Cues from researchers were found to scare the goldfish, also not really lining up with the claim. Environmental stress has a greater impact on goldfish behavior than food does. That one is a little bit tricky because it mentions the food, but remember, we're really focusing on the feeding times and the positioning, so this one doesn't work either. And just like that, we've got our answer A. College Board seems to be making small adjustments on each new exam, but the questions we're about to go over are types of questions that keep showing up over and over again on the SAT. And make sure to pause the video and try each of these questions on your own first. So before we get into it, let's talk about what every part of y equals mx plus b represents in the context of a word problem. So y is going to be our total. X is going to be the thing that affects the total, which is usually time or a number of items being purchased or something like that. M is obviously the slope, but we want to look for a constant rate of change. Think like miles per hour. And then B is our starting point. So let's take a look at this question. And a nice shortcut is go ahead and just skip to the main question. That is usually the last sentence. Which of the following is the best interpretation of the number 2? All we have to do is figure out 2 is which of these? Is it y, x, m, or b? So in this case, it's going to be taking the place of m, right? So we're going to look for a constant rate of change in our answers. A says the number of years it took. So a number of years is not a constant rate of change. So A is out. B says the average number of feet that the tree grew per year. So that is a constant rate of change, probably our answer. The height in feet, height is going to be a specific number. Again, not a rate. The average number of years it takes similar trees to grow? No. So the only rate of change is B. So without even really reading the question, we know our answer is B. Next up, we have constant questions with infinite solutions and no solutions. This one says it has infinite solutions. Basically, this means that these two expressions are going to be exactly the same. One of the tricks with these is that you really don't need to worry about your leftover number that is not attached to x. So this 16 and this 8, if it's infinite solutions, they are going to end up being equal. But if it's no solutions, then these numbers would never end up matching up. Regardless, you can focus on what's attached to x and just make sure that those match up. So what do we multiply by to get 2x? We multiply by 2. So A is going to have to be 2. Let me show you one that has no solution so you can see what I mean. Same thing. We're just going to focus on getting something that's attached to x. So for this one, we're going to have to take an additional step and actually FOIL this out. B times x is going to be bx. I'm just going to write it over here. Negative 2 times x is going to be negative 2x. So we have bx minus 2x. And I was telling you that we don't want to worry so much about the number that is not attached to x. So in this case, it would be 8. What we do need to do is we need to move the 2x over so that the bx is by itself. So we're going to add 2x to both sides. I'm going to go ahead and draw this down here. And then we get bx equals 2x plus 8. And again, we do not need to worry about the 8 here. So we're actually just going to get rid of it. Basically, bx equals 2x. So it looks like, again, our constant equals 2 because they need to match up. Next up, we've got probability questions. And for these guys, we really want to just think about what does probability look like on the SAT. We're always going to have some sort of desired outcome divided by the possible outcomes. And let me give you an example here. Let's say I wanted to know if I flip a coin, what is the probability that I will land on heads? So there's only one head. My desired head is 1, but what's possible? There are 2 possible outcomes. There's heads and tails. So possible would be 2. That's a very simple and straightforward example. But if we can identify our possible and our desired, it really becomes quite easy. So if you haven't already, pause the video and try this question using that principle. But I'm going to go ahead and get started. So again, I like to go straight to the main question and kind of work my way and then decide what parts of the text I want to look at after that. It's asking me the value of x. So right away, I'm going to look and I'm going to see that x is, here in this chart. So I know that that's what I'm aiming for. Now, picking through the rest of the question, I can see that the first sentence is really just giving me facts that I don't need to know. I don't care what these things actually mean. I just want to focus on the numbers. And then the second sentence is describing the chart that I can see. So I also am going to ignore that. And what I really want to focus on is if one of these people who is rhesus negative. So that if statement, if one of these people who is, these phrases are indicating that this is my possible, because we're not talking about the entire chart. We're talking about one of the people who is rhesus negative. So where's my rhesus negative? Well, we see that this says rhesus right here. And then there's our negative. So basically my possible is going to be here. So before I do anything else, I'm going to go ahead and write my possible. We've got 7 plus 2 plus 1 plus x, or 10 plus x. We know that's our denominator. Okay, now let's figure out what our desired is. The probability that the person has blood type B. So we're going to pause there as well. We look at blood type B, and again, we're only looking at this part that I circled. Blood type B is 2. So we know that our numerator, our desired, is 2. Cool. And then finally it says is. A little trick for you. The word is means equals. That is how you translate that into math. Let me move this over. Is 1 out of 9. So this equals 1 out of 9. All right, now we've just got simple algebra. We can go ahead and cross multiply, which means we're going to multiply our diagonals. So diagonal from 2, we have 9. So 2 times 9 is 18. And this will be equal to our other diagonal, which is 1 times 10 plus x, which is still just 10 plus x. From here, we subtract the 10, and then 8 equals x, which means our answer is 8. Our next question type is scatter plots / lines of best fit. And there are 2 things that I want you to be careful of when you encounter these types of questions. Number 1, be careful and make sure that your y-intercept is actually your y-intercept, because sometimes that is not going to be the case. And the way to check for this is just to make sure that you actually do have 0, 0 in the corner here. In this case, we do have 0, 0. But for example, if this 0 were, I don't know, 20 or 30 or anything other than 0, then what looks like our y-intercept would not actually be our y-intercept. The other thing I want you to check for is to make sure that the x-axis and the y-axis are growing at the same rate. And sure enough, they are not. The x-axis is growing by 10 each slash, and the y-axis is growing by 1 each slash. Why is this important? Because if you try to just eyeball what's going on with the slope, for example, you're going to be in big trouble. All right, now that we've looked at that, let's see what's going on here. Basically, it gives us the equation, and then it asks us what's being predicted. So going back to those definitions we talked about at the beginning of the video, our constant rate of change should be 0.096, because that's where m goes, right? Remember, we're thinking y equals mx plus b. So that's our constant rate of change. And then our starting point is going to be negative 0.488, more or less, right? So now what we can do is just go through and eliminate any answers that are telling lies. A says each year between 1940 and 1910, so every year, now keep in mind this is going by 10 years, right? Each year, the average increase was $0.096. So let's kind of look at this. If we go roughly from here to here, that's about $1, right? And that's over the span of 10 years. So about $1 would be 0.96. If that happens in 10 years, then 1 year we would just move the decimal over one place, right? And we would get 0.096. So not only is that the constant rate of change that we were looking for, it also makes sense when we look at it visually. So we don't need to go any further. A is our answer. All right, our last type of math question I'm predicting will be on your SAT is a lines and angles based question. And for these questions, there are several concepts that you're going to want to know to sort of play ring around the rosy and get to your answer. For this one in particular, the first geometry rule I'm going to use is the straight line rule, which is basically a straight line is 180 degrees. And we always want to start with something we know to figure out something we don't know. I see that S as a straight line. So if on one side of this straight line, we have this angle that's 106 degrees, and we know that the full straight line, that angle is 180 degrees, all we have to do is take 180 and subtract 106 to get the missing angle. So that would be 74. So we know that this little angle right here is 74. Now we can use the same 180 rule, but the 180 rule of triangles. Triangles also have 180 degrees. So now we can go 180 minus 74 for this angle, minus 23 for this angle, and we get 83. So we know this angle down here is 83. And then one more time, we've got another straight line here. So 180 minus 83 is going to be 97, which is X, our answer. We've got questions that look like they're going to require the quadratic formula. So if we take a look at the quadratic formula, we've got negative b plus or minus the square root of b squared minus 4ac all over 2a. Because of this square root, a lot of the time you end up with square roots in your answer choices. So when we look at this, it seems like we might have to use the quadratic formula, which is a little bit annoying. And in truth, we could use the quadratic formula for this one. We could also use substitution, which is again going to be annoying, but there is a way that looks like it's going to be faster, and in this case it would be, and then there's a safer, fast way. Let me show you. So the way that looks really fast to me is testing out the answer choices. This strategy is also known as back solving. And the reason this looks very tempting is if we take the first answer and we plug it into the top equation, we get 1 plus the square root of 3 minus the square root of 3 equals 1. And that's definitely true, right? Because we're getting rid of the square root of 3, 1 equals 1. And if you were just testing the top equation, you would get lucky and you would answer A, because that does happen to be the answer. But the problem is, if you're being careful, which you should be, you get down to C and the same thing happens, right? You have 1 plus the square root of 5 minus the square root of 5. And yeah, that equals 1 too. So now at this point, we're going to have to plug them into the bottom equation, which, as you can see, is not going to be nearly as fun. So what would I recommend? Believe it or not, we can use Desmos on this. I know it doesn't look like it because of the radicals, but bear with me. If I pull it up and we go ahead and put in our system of equations, it is asking us which ordered pair is a solution. So if we can match one of the answers to one of our solutions, we should be good. So if we look at this one, we've got 2.732, 1.732. And from here, it's as simple as plugging in our answers to see what they look like in decimal form. So A, we've got 1 plus square root of 3. And by the way, I typed in SQRT, a little shortcut for you. And by golly, that's 2.732. Okay, well, what about the square root of 3 by itself? SQRT. 1.732. So, luckily it was A, so we got our answer. And this time we know for sure it is a solution. But if it didn't work, we'd go through and then we would end up getting our answer that way. So a little extra step, but I think a lot faster than some of the other methods available for this one. Next up, I've got the rule of 180. And the rule of 180 is more than just one rule in a way, because we can think of the rule of 180 as 180 degrees in a triangle, which is what it is in this case, but also 180 degrees in a straight line, which it also ends up being. Along with that, we've got a little bonus, which is isosceles triangles that will come into play for this one. So let's take a look here. We know that our goal is just to find out what x is, right? What is the value of x? And with geometry, I highly recommend labeling everything first. So let's do that. We know that EBC is 45. So I'm going to stick a little 45 up here. And in case you're not sure how to read these, basically the letter in the middle is the angle that we're looking for. And then ACD is 104. So ACD, this is 104. And then importantly, I almost skipped this. The very first thing it says is AC equals CD. So we can mark that AC equals CD. And this is super important because this goes to the whole isosceles triangle thing that I was talking about. If you have two equal sides, it means the corresponding angles are also equal, and you have an isosceles triangle. So basically D and A, these two angles are also going to be congruent. And now we can pull in the rule of 180, right? Because we know that the top of this big triangle is 104 degrees, and we know that there's only 180 degrees in a triangle. So if we take 180 and we subtract 104, we get 76. And we know that that has to be split up between these two angles, right? So we can label a little bit more. Split up that 76, that is to say divide it by 2, and we get 38. So now we also know that both of these angles down here are 38. And now we've already begun to engage in what I like to call ring around the rosy. We're going around, we're seeing what can we figure out? What can we figure out that's going to get us closer to that x? And we are actually really close to solving this now. Just a couple more things. We're going to use the rule of 180 again. This time it's going to be the straight line rule. We know that this is a straight line, so it's 180 degrees. We know that this side of the straight line is 104 degrees. So again, we're going to do 180 minus 104, but we already did that. We know it's 76. So we can label this angle 76. And now we can use the triangle rule of 180 to get the last angle in this triangle. Let me switch colors here. So we got 180, and this time we're going to subtract 45, and we're going to subtract 76. And I'm just writing this out so you can see what I'm doing, but just use your calculator. That's 59. And then there's another rule here, which is the vertical angles rule. Basically, whenever you have two tips touching like this, those angles are congruent. So if that's 59, we know that this is also 59. And then, as you can see, we just have to do that rule of 180 one more time. Now we're subtracting the 59 and the 38. And we get 83, which is x. And that's our answer. So I said the rule of 180, with a little bonus rule of isosceles triangles. We should probably add another bonus rule in there, which is vertical angles. So really, it's just common geometry rules that you ought to know. And these are rules that are not on the reference sheet. So you really do need to have these memorized. Next up, we have
so many linear equations.
There are going to be so many linear equations on your exam. How do I know this? Because 32% of the questions in College Board's question bank are linear equations. So they're inevitable. And something that is really helpful to remember with linear equations when they are word problems is what each component of slope-intercept form represents. So just a quick refresher for you, we've got y equals mx plus b. And you should know that y is y, x is x, m is the slope, and b is the y-intercept, right? But in the context of a word problem, what do these things represent? Well, y is going to be your total. X is going to be the thing that affects your total. This is often time or a number of items being purchased. M is your constant rate of change. So if x were time, then m would be like, miles per hour. If x were an item that you were purchasing, m would be the cost of that item, right? So it's the rate of change in relation to x. And then b, your y-intercept, is your starting point. All right, with all that in mind, let's actually take a look at this problem here. And I do like to go to the main question first and decide how much of the rest of the question I want to read based on that. And the main question says, what is the best interpretation of the slope? So this is perfect. We can look at our little cheat sheet here because it's all about representation, interpretation, right? So the slope, according to what we just talked about, is a constant rate of change. So I'm going to eliminate any answer that is not a constant rate of change. Each game costs 25. That would be a constant rate of change, right? We talked about it being, the cost of things that are being purchased. The video game system costs 100. And I can already tell what's going on here because we know we're going to have multiple games for one system. So the system would be kind of like the starting point, the y-intercept, because you need to buy the system before you can start playing games. But we could also look at the other sentence here, and it tells us that more or less. But either way, B is not a constant rate of change because we're only going to buy one video game system. Again, C, only one video game system. And then D is also a constant rate of change. Each game costs 100. So now I just need to figure out, is the slope actually 25 or is it 100? We could grab a couple points and use the slope formula, but I'd rather just eyeball it because there are some pretty clear points here, right? We just need to do rise over run. So here we have 100, and then we want to draw a little staircase. So rise over run. We go up 25 because once we get here to 1, it's 125. Same thing here, rise over run. We can see that we're going up by another 25. So my answer is A. Next, we've got margin of error questions. I feel like these are sort of a sleeper that not a lot of people talk about, and they're not super common. If you're going to run into one, you're probably just going to run into one on the exam. But if you know how to handle them quickly, those are extra points that are very easy to attain. Basically, with margin of error, we need to remember that a margin of error says it is likely that the real percentage is either, this amount higher or this amount lower within that range. So for example, if I said, I did a study and according to my study, 64% of cats are evil, but there's a margin of error of 4%. That would mean it is likely, and it's important that we remember likely here because we don't know, but we can say with confidence that it's likely between 60%, so that's 64 minus the 4%, and 68%, so adding that percentage to the 64% of cats are evil. So that's all we need to remember for margin of error. The word likely, and we're going between a range of subtracting and adding the margin of error. And like I said, I do like to start with the main question, which is why I immediately saw that this was a margin of error question. It says, which is the correct statement on the given margin of error. And the reason that this is so fantastic is we don't have to look at this chart. We don't have to look at the whole question. We just have to figure out what the margin of error is and then sort of cherry pick from there. So here it says the estimate of heavy texters is 30%. So that's like my 64% of evil cats. And then the margin of error is 3. So in my head, I'm thinking it's likely that 27 to 33% of teens are heavy texters. And notice I'm not even looking at this chart because of this. So hopefully I don't have to. All right, and I'll write that down so we don't forget. Get rid of the cats. Cool. All right, now we eliminate answers that will not match that, basically. Approximately 3% of teens who are classified as heavy texters are not really heavy texters. No, it is not possible. Immediately, I'm seeing not possible. That's an extreme absolute statement, so B is probably not going to work. That sort of language is something you definitely want to look out for. Not possible that the percent of teens who are heavy texters is less than 27. So it's not likely, but it is possible. So that's why we get rid of B, and that's why I emphasized the likely. It's really important there. C, the percent of all US teens who are heavy texters is 33. That's another extreme absolute statement. It's saying it is. It's not using likely. So C is out. It's possible, but it's not just the truth. And then D, it is doubtful. So doubtful is sort of the opposite of likely. It is doubtful that the percent of teens who are heavy texters is 35. Yeah, because it's likely it's 33 at the highest. So it would be doubtful that it's 35. So D is our answer. Next up here, we have what I like to call scary constants. And they are scary, but we shouldn't be that scared of them. This problem in particular is rated at a difficulty level of 3. So basically, the highest difficulty level according to College Board. But there are 2 easy ways that we can solve this. For sure, we could do a whole lot of substitution and solve it on paper, but for systems of equations, your first instinct should be to try out Desmos if you don't see another quick solution. Now, I don't think Desmos is the fastest way to solve this one, but let me show you how that would work real quick. Basically, we put both equations into Desmos, which I've done here, and because there's a constant involved, we're going to have to add a slider. So you click this little button that says Add Slider. And then what the slider is going to do is allow us to change the value of t. And the question is asking, what is the value of t? So The only hint we're given is that the system has no solution. No solution means the lines never touch. So I would need to move this slider around so that the lines are not touching and that they will never touch. Basically, they need to be parallel. And you can see when I get to 8, they are indeed parallel. Visually, it's kind of hard, but if you zoom in, you can tell. And if you wanted to double check, you could plug 8 back into the equations to make sure it works. So Desmos would work like that. However, I think there's actually a really fast way of solving this. So like I said, a system of equations with no solution means they never touch. As I just showed you visually, it means they are parallel. And if they're parallel, it means they have the same slope, which means they should have the same coefficients in front of x and y. Another cool thing is, regardless of if it has no solution or infinite solutions, we can focus on those coefficients in front of x and y, because no solution means that the constants, that is to say the leftover numbers that are not attached to x and y, they're never going to equal each other. With infinite solutions, they will equal each other, but we could still just focus on the coefficients because they're also going to equal each other. Anyway, let me stop saying equal each other and actually show you what this looks like. So I am just going to worry about getting the number in front of x to be the same because I know they have the same slope. So that's literally all I'm going to do. So the first thing I want to do is get these looking more like each other. The bottom equation, we have y on the left side, but then x is on the right side. So I'm going to just do a little flippity-doo-dah-day here and make that the case for the top equation as well. I'll start by moving the 10y over to the left. So we get negative 16y because I subtract 10 from both sides. And then I want my x to go over here. So I'm going to subtract 4x, which means that would equal negative 4x. And remember, I don't care about the constant, so I'm not going to even worry about it. I'm just going to leave it out of the equation. And I'm not particularly fond of negative numbers, so I'm just going to multiply this whole equation by -1 to turn these positive. Now, let's write the bottom equation, again, omitting the constant, because we don't care about the constant. Doesn't matter. Ty equals 2x. All right. Now, remember what I said. They have to have the same coefficients. So right now, if we have 4x up here and 2x down here, how do we get the bottom to be 4x? We just multiply the whole equation by 2. So then we get 2ty equals 4x. All right. And remember what I said, they have to be the same coefficients. So the 4s are matched up. That means that the y coefficient should also be matched up. So if we get rid of that y now, basically these should equal each other. Moving over here real quick, 16 equals 2t, which means t equals 8, right? We divide by 2. So our answer is 8. And I was writing all that out for you, but honestly, most of that, if not all that, should be able to take place in your head once you get used to it. For me, as soon as I wrote down these guys here, I'm immediately saying that we multiply 2 by 2 to get to 4x. So then what do we multiply by 2 to get to 16? 8. And at that point, I already know the answer is 8. So that's why it would go really quickly for me if I use this method instead. Definitely look for shortcuts when you come across these scary looking constants. For sure you can use Desmos, but as you can see, a lot of the time there's even better shortcuts. All right, and here we have percentages, and you are certainly going to be encountering percentages on the SAT. If you want me to make a more detailed video on the different types of percentage questions, let me know in the comments, but for now, let's just address this. We know from the main question that we are looking for the discount. And I like to start with the main question so I don't get distracted and lose sight of my goal. It says the total cost of this purchase was $75. That was the total cost. Emma's going to get a discount code to save 15%. That's subtract 15 off the total cost. So basically, we're taking that 75, we're subtracting 15%. And some of you smarty pantses out there might be like, ooh, I know. If we multiply 75 by 0.85, we're going to get the amount that Emma paid. And you're right. That's totally going to work. But remember, we're not looking for what she paid. We're looking for the discount. So we actually just want to multiply by that 15%, which is, 0.15. Throw that into Desmos if you want, and we get 11.25 as our answer, which is B. All right, this one's going to be words in context. So I'm going to read through. As an undergraduate researcher, this Jennifer contributed to a study challenging the accepted view. All right, so we're challenging a view that among prehistoric peoples, female participation in hunting was blank. The research team's review of data from these eras and early burials in the Americas revealed that, in fact, so this should go against whatever this is, as many as half of the hunters in those populations were female. Okay, so half of them being female, we want to go against that because we're challenging that. We have in fact, so I'm going to say something like female participation was lacking, something like that, because half of hunters would not be lacking, so lacking would be the opposite, kind of what I'm looking for. Inevitable, nope. Satisfactory, no. Satisfactory is like enough. Negligible, so negligible is definitely lacking. Negligible means such a small amount that it like doesn't even matter. So that would be my answer, and I'm just gonna circle it and be done. If you're confident, choose your answer, move on. If you're not 100% confident, make sure to eliminate 3 answers first. Command of evidence. Rejecting the premise that literary magazine Ebony and Topaz should present a unified vision of Black American identity, this guy fostered his contributors' diverse perspectives by promoting their authorial autonomy. Johnson's self-effacement diverged from the editorial stances of these other guys whose decisions for their publications were more blank. Because it says that Johnson's self-effacement diverged, we know that it's going to be different from these other guys. So self-effacement on its own is sort of not trying to like have all the attention on you. And then the sentence before that, it says used his contributors' diverse perspectives. So if we're looking for the opposite of that for these other guys, their decisions would be more, I don't know, like self-centered, or at least what's the opposite of diverse perspectives, or one perspective, something like that. So that'll be my prediction. Then looking at my answer choices, proficient definitely doesn't work there because proficient means you're like effective, good at doing something, not self-centered or from one perspective. Dogmatic I could see working because dogmatic means you are sticking to a dogma, a set of beliefs, and usually it's used in a negative way. Like if you're dogmatic, you just sort of follow the rules of your dogma blindly. Dogma being like a kind of teaching. So that could fit with the one perspective at least, not necessarily the self-centered. C, ambiguous. Ambiguous is just like it's unclear, so that doesn't work. Unpretentious. So self-centered is pretentious. So unpretentious would be the opposite of that. So that would be like the opposite of part of my prediction. So I'll say D is out, and then B is going to have to be my answer. And yeah, that works. So we've got a structure and purpose question here because it's asking about the main purpose of the text. So I like to definitely check out the date and any information they're going to give me up top. Specifically the date because it just sort of prepares me for, either words being used in a way that they aren't normally used or just words being used that I don't know. And it's telling me that Humphrey Davy was a prominent British chemist and inventor. So I'm going to pay attention. That's probably somewhat important since that's the only thing they're mentioning here. All right, we get years ago, this American savant was in London. He observed at an evening party a certain coxcombical fellow. All right, coxcombical, not a super common term. Let's work through this as if we don't know what it means. We're going to try to figure out what it means based on the context, right? As he thought, an absurd ribbon in his lapel, full of smart banter, whisking about to the admiration of as many were disposed to admire. Okay. So based on this, I'm thinking coxcombical is maybe sort of loud, not loud, like literally loud, but personable, maybe like annoyingly personable and friendly. Like he's trying to get people to like him, with the smart banter, trying to get admiration. He's got this really obnoxious ribbon, apparently. So perhaps he's a bit like conceited, full of himself, that sort of thing. Anyway, so then we get great was the savant's disdain. And then remember, the savant is the person who's observing this guy. So now we know this guy is not fond of him. Disdain means he really doesn't like him. But chancing erelong to find himself in a corner with the jackanapes. I don't know what a jackanapes is, but we know he's calling this guy a jackanape. So maybe it's also like a coxcombical fellow, a jackanapes, an absurd man who's full of himself. That's what I'm going to assume. Got into conversation with him and was somewhat ill prepared for the good sense of him. Okay. So he got into conversation. He was kind of taken aback by how friendly he was, it seems. Oh, it even says thrown aback, but was altogether thrown aback upon subsequently being informed that he was no less a personage than Sir Humphrey Davy. Okay, so the language there's, again, not something we would hear today, but basically saying he was surprised that this is in fact Sir Humphrey Davy, which we know is a prominent British chemist and inventor from the top there. Cool. All right. So main purpose of the text. With fiction, if you're looking for main purpose, I would just focus on like what happened in the simplest terms. And what happened in the simplest terms was some guy got surprised that I was about to say something inappropriate, that this foolish, conceited man was a famous guy. Something along those lines is what I'm thinking. So that'll be my prediction there. All right, now I'm going to eliminate answers that don't match that prediction. A, portrays the thoughts of a character who's embarrassed about his own behavior. No. It presents an account of a misunderstanding. Surprised that this guy was famous. That's a misunderstanding. I'll keep B. Offers a short history of how a person came to be famous. No. Explains why one character disliked another. Tempting. Like, this definitely happens, but is that the main purpose? I think because it ends with Humphrey Davy, and also because they give us this information about Humphrey Davy, it's probably more important that we have this the surprise. And also, the explanation of why he dislikes him is pretty brief. It seems like he's kind of jealous of him, so I don't think that's going to be our answer. So choice B is going to be our answer. All right, here we've got main purpose of the text. So I'm going to just read through the whole thing and come up with a prediction for that. Studying late 19th and early 20th century artifacts from an agricultural and domestic site in Texas, this archaeologist found that Black women employed as farm workers utilized hook and eye closures to fasten their clothes at the waist, giving themselves a silhouette similar to the one that was popular in contemporary fashion and typically achieved through more restrictive garments such as corsets. All right, let me just unpack this for myself. So basically we're seeing these Black women made clothes to look like popular fashion. It's kind of how I would simplify things. And then Fluellen, that's the archaeologist. The archaeologist argues that this sartorial practice shows that these women balanced hegemonic ideals of femininity with the requirements of their physically demanding occupation. All right, and then to kind of put that into my own words, I would say something like, well, it talks about ideals of femininity. So I could say to stay feminine, even though working, something like that, demanding occupation. Say, even though working hard. So that's kind of my summary of what's actually being said in the passage. As far as purpose goes, purpose is usually like, what is the text doing? So I would say the text is giving us evidence that these women were doing this, more or less. So I'll kind of just use that as my prediction. A, to describe an unexpected discovery. Not really an unexpected discovery. It's more like I said, just explaining to us that this is what we think was going on. To discuss research investigated in the ways the Black female farm workers used fashion to resist traditional gender ideals. So they were trying to actually fall in line with gender ideals, like to stay feminine. So that's the opposite of what we said. To evaluate a scholarly work that offers explanations for the impact of urban fashion ideals on Black female farm workers. No, it's not evaluating the work and offering explanations for the impact of urban fashion ideals. It's just kind of saying that they were trying to still stick with those fashion ideals, but I don't know if that's so much an impact. I don't know. I'm going to keep that one because it kind of works. D, to summarize the findings of a study that explored factors influencing a fashion practice among Black female farm workers. See, I like that a lot better because it is summarizing the findings, basically that they were doing this thing to stick with the fashion that explored factors influencing a fashion practice. Because the focus was more on them doing this fashion practice rather than the impact that fashion ideals had on them. So D is going to be my answer for this one. All right, I can tell from the question stem this is going to be a detailed question. Anytime we see something like, what does the text most strongly suggest? And then something specific. So I'm going to be looking for the use of this thing's performance space specifically as I read through this, because it's not about a main idea. It's more about the performance space. So the most recent iteration of this immersive experience, and then we have some non-essential info, transforms its performance space. Okay, so here I want to really pay attention, even though this is non-essential information, because we're starting to describe the performance space. I want to make sure I read everything. 5-story warehouse into a 1930s era hotel. Audience members who wander through the labyrinthine venue at their own pace and follow the actors as they play out simultaneous interweaving narrative loops confront the impossibility of experiencing the production in its entirety. Okay, so for the performance space, basically we're getting play taking place, I think it's a play, all over warehouse. So just kind of putting things into my own words. The play's refusal of narrative coherence thus hinges on the sense of spatial fragmentation, hinges on the sense of spatial fragmentation. So that's basically a fancy way of saying it relies on this 5-story warehouse that the venue's immense and intricate layout generates. So what does it suggest? I mean, I guess it suggests that the performance space is like part of the play itself. So I'll say something like part of the play itself.
Part of your play.
And let's eliminate. The choice of this venue likely enabled the play's creators to experiment with the use of space in a way that venue from earlier productions. This is a big red flag. Doesn't mention any earlier productions in the text, so that is an easy no. Audience members likely find the experience disappointing. No, we're not worried about that. Again, I'm looking for like the performance space being part of the play itself. The production's dependence on a particular environment would likely make it difficult to reproduce exactly in a different space. Yeah, if it's part of the play itself, it would be difficult to produce somewhere else. So I'm going to keep that one. Audience members who navigate this space to a recommended itinerary will likely have a better grasp of the narrative than audience members who depart from the itinerary. I mean, maybe, but there's no mention of an itinerary anywhere. So again, that would be like outside of the text. We don't care about that. And it doesn't go with what I said. So choice C is my answer here. All right, I'm going to start with this view so that you can pause the video and try this on your own first. But for these, if you know me, you know I usually actually don't like to look at the graph at first. So I'm going to go ahead and zoom in as I work through this. And basically, I'll look at the visual aid if I need to look at the visual aid. But let's see. We want to complete the text, which basically means we want to support the conclusion or the hypothesis or whatever. Indeed, it's a conclusion. They concluded that REM sleep may not be homeostatically regulated. Okay, so REM sleep may not be homeostatically regulated in fur seals. And then it says citing as evidence that, so again, if we're completing the text, we're giving evidence to support that conclusion. Now, I have no idea what homeostatically regulated means, so I'm going to glance through the passage and look for it. And indeed, right here in the first sentence, it says, homeostatically regulated, animals compensate for periods of REM sleep deprivation by increasing subsequent REM sleep. So in my own words, that would be something like make up for lost REM sleep later, right? So that's what the regulation means. So now as I go through my answers, I want to support the idea that fur seals do not do this. They are not regulated. They do not make up for lost REM sleep later, all right? And I'm going to see if I can get away with just eliminating answers, but again, I'll look at the graph or whatever if I need to. Okay, so the seals in the study didn't show significantly less REM sleep during the second day after returning to land than they did the first day. So real quick, I want to make sure that I understand what happened the first day and the second day. I'm going to assume that they lost sleep the first day. Again, if I go back to the paragraph, when on land, fur seals get enough REM sleep, but during the weeks they're in the water, they get almost none. And then it says in the study, they recorded it, once they had returned to land. So indeed, this is a study right after they came back from the water where they weren't getting sleep. So if they showed less REM sleep during the second day after returning to land, that's just comparing 2 days on land, which doesn't help us at all. We're basically looking for them making up for lost sleep after they get back. So that's not even connected. So A is out. B showed no significant differences from one another in baseline levels of REM sleep. That doesn't mention the water versus the land at all. It's just talking about them compared to each other. So that doesn't work either. Didn't consistently demonstrate a significant increase in REM sleep after their period of deprivation in the water. That's specifically talking about after deprivation in the water, didn't increase REM sleep, didn't make up for lost REM sleep. So that's looking really strong. Let's look at choice D, because sometimes you'll get two answers that work and then you have to look at the graph. Showed no significant difference between REM sleep after returning to land and REM sleep while in the water. So that one's kind of tricky because no significant difference would not necessarily be making up for lost REM sleep, but it's not specifically talking about, not making up for lost REM sleep after returning. It's just saying that there was no significant difference. So it kind of works, but it is not as strong. So D would be out, and my answer would be choice C. All right, we got an inferences question here. So for these, I like to kind of work backwards. Young and colleagues' recommendation therefore implies that HST, because this is kind of acting as the question stem for a lot of other types of reading questions where it's going to tell me what I'm aiming for as I read through the rest of the passage. So it therefore implies that something about HST. So as we read through the rest of this, just know that we're aiming for some sort of implication about whatever HST is. All right, so HST is projected to maintain operation until at least 2030, but it has already revolutionized this imaging system, this image of solar system bodies this seems like it's probably detail I don't need to worry about. Notwithstanding, this is going to be a transition, and I get excited about transitions because they kind of point to things I should pay attention to, that only about 6% of the bodies are within the solar system. Okay, so it's basically it's saying HST has done important stuff, although this only includes 6% of bodies that are within solar system. So I'm focusing on that. And then we get this researcher and colleagues assert, so they're making some sort of an argument that a new space telescope dedicated exclusively to solar system observations would permit an extensive survey of minor solar system bodies and the long UV observation to discern how solar system bodies can change over time. Okay, so basically they're saying if we get a new telescope that's dedicated exclusively to solar system observations. Because remember, the HST is only doing about 6%, would permit an extensive survey of this. The recommendation therefore implies that HST blank. So the implication to me would be if we have a telescope that's exclusively looking at solar system bodies, then the HST could focus on things outside of the solar system since it was only doing about 6% anyway. And now we have this other telescope that's dedicated to it. We could basically have the HST for outside of the solar system and then this new one for inside the solar system. So I'm going to say can focus outside solar system. All right, let's take a look. Will likely continue to be used primarily to observe objects outside the solar system. Well, I usually like to eliminate, but that is such a close match. I'm just going to go ahead and circle A. That's my answer, and we'll move on. All right, got another inference here. And normally I like to start with the last sentence, but it's already looking pretty long, and I can see it's kind of mentioning stuff that I'm going to need to know about. So I'm just going to start from the beginning here and try to wrap my head around what's going on from the start. The one thing I will note is that suggesting that during the Bourbon Restoration. So basically we want to make some sort of a suggestion about what was happening during the Bourbon Restoration. During the Bourbon Restoration, the right to vote required that in part a person paid at least 300 francs in direct taxes to the government. Okay, so to vote must pay. I'll say something like that. And it says the four most common taxes were levied on real estate, the doors and windows of taxpayer homes, the rental values of homes, and the businesses of artisans and merchants. Okay, so basically, this was mostly affecting real estate. Although relatively few people paid the tax on real estate, it was the main means of voter qualification and accounted for over 2/3 of government receipts during this period. Okay, so if it was the main means of voter qualification, I would say maybe we could infer that people with real estate were voting more during this period because you had to pay this thing in order to vote. So we'll say people with real estate voted more. That'll be my prediction. Those people who had the right to vote most likely had substantial holdings in French real estate. That's literally what I said, but this one is kind of scary, so I'm going to make sure and eliminate the other answers. Voting habits of French artisans and merchants were effective in reducing tax burdens? No. Number of doors and windows was kept to a minimum? No. French people with significant foreign investments were unlikely to have the right to vote? No. So choice A is definitely going to be my answer. Cool. That ended up being a little bit easier than I thought. All right, we've got cross-text connections here. So we're usually going to have one text responding to the other, but in this case, we have a little bit of an oddball. It says, what would the two texts most likely agree with? So I'm actually just going to read through these, kind of get myself a main idea for both of them and try to find a connection between the two where they agree with each other. So text one, this guy disputed claims that the two noble kinsmen was co-authored by Shakespeare and this guy Fletcher. He felt Fletcher's contributions were obvious. Fletcher had a distinct style in his other plays, so much so that the lines with that style were considered sufficient evidence of his authorship. But for the lines not deemed to be by Fletcher, this guy felt their depiction of women indicated that their author was not Shakespeare, but Philip Massinger. All right. So basically, I'm seeing the argument is that the two noble kinsmen, I'll just call it TNK, not by, we'll say Shakespeare S and F, so Shakespeare and Fletcher, but by F and M, M being Philip Massinger. That's kind of like the main thing that I'm seeing there. Looking at number two, scholars have accepted that TNK was co-authored by Shakespeare. since the 70s, it appears in all major one-volume editions of Shakespeare's complete works. Though scholars disagree about who wrote what exactly, it is generally held on the basis of style. Shakespeare wrote all the first act and most of the last, while John Fletcher authored most of the 3 middle acts. Okay, so this guy is saying T&K was authored by S&F. Now, as far as what they have in common, it looks like they both agree on the F, like they both think Fletcher was involved. So that'll be my prediction. They would agree that Fletcher was involved. All right, let's take a look here. John Fletcher's writing has a unique, readily identifiable style. So that's not exactly what I wrote, but I do remember we see like on the basis of style, Fletcher had a distinct style. So that's literally mentioned in both texts, so I'll keep that. B, the women characters in Fletcher's plays are similar to women in Massinger's plays. No, that mentions Fletcher, but Massinger was only mentioned in the first passage, so B is out. C, T&K belongs in one volume. That doesn't mention Fletcher at all. D, Massinger. Again, Massinger was only mentioned in passage 1, so gotta be A. All right, we've got standard conventions of English, specifically punctuation, so I'm just gonna start from the main sentence. With this novel data set, the team was able to determine how current-driven mixing varies across regions and what impact it has on the distribution of heats. Okay, we have 2 noun phrases, not 2 independent clauses, so we don't need any punctuation. My answer is choice D. And if what I just said doesn't make sense to you, you might want to go ahead and take a look at my punctuation and grammar course, which will teach you how to solve these just as quickly as I solved that one. Link in the description. All right, another boundaries question. So I'll start just from, actually the whole thing is one big sentence. So I guess I'll start from the beginning. This researcher developed a process for increasing tensile strength measured in or GPa of silkworm silk by dissolving and reweaving the silk in a solution of iron metals, this and this. Z, increased the amount of force required to stretch it from approximately 0.5 to 2. So for ones like this that I think are even more challenging, I want to pay attention to whether or not I have independent clauses. So let's start by seeing if I could end the sentence after silk, since I see D as an option. Researcher developed a process for doing this thing of silkworm silk. This is non-essential information, so I could ignore it. This person developed a process for increasing the tensile strength of silkworm silk. Period. That would work. Do I have an independent clause starting here? Dissolving and reweaving the silk in a solution of these things. Z, increase the amount of force required to stretch it from this to this. That's also a full sentence. So yeah, my answer is D. Got a form, structure, and sense, aka a grammar question here. I like to at least start with the sentence with the blank space and then read more if I need to. The animal which lays eggs but also nurses blank young with milk has since been classified as whatever. Okay. And it looks like I'm dealing with pronouns. So really, I just need to figure out what is my antecedent. Well, my antecedent is the animal. The animal lays eggs but also nurses its young with milk. It is singular because the animal is singular, and D means it is. So my answer is choice C here. All right, more grammar here. I'm just going to read the whole thing because it's incredibly short. Known as Earth's living skin, biocrusts are thin layers of soil held together by surface-dwelling microorganisms, such as fungi, lichens, and whatever, fortifying soil and arid ecosystems against erosion, comma. All right, so that's structure where we end with a comma, and then also in all the answer choices, we have different starting noun phrases. That means we're dealing with modifiers. So I just need to figure out what or who is fortifying soil. A recent study's estimate. An estimate cannot fortify soil. A is out. An estimated 60% reduction. A reduction in something cannot fortify soil. So B is out. These crusts are a thing, so they might be able to fortify soil. I'll hold on and then maybe we'll debate between this one and D. A recent study. Oh, or not. A study can't fortify soil. So even though I have no idea like exactly what's going on here, it's very scientific, I can tell pretty easily that 3 of these things cannot fortify soil, while one of them potentially could, and that's going to be my answer, choice C. We've got a transitions question here. In a heated debate in biogeography, the field is divided between dispersalists and vicariancists. Blank, there are those who argue that dispersal is this thing, and those who insist that vicariance is. Okay, so it seems like we get this vague statement about the dispersalists versus the vicariancists. I don't know what that means, but it seems like they're sort of explaining to us what that means. Again, the language here, it seems very scientific, but basically it's like an explanation of what these things are. So I'm looking for some sort of a clarifying transition, like that is to say, so that is to say would be my prediction here. And then normally I would start eliminating, but I see that is, which is literally the same thing as that is to say. It's just a shortened version. So my answer is D. We've got rhetorical synthesis. So I'm going to start by ignoring the notes, and then I'm going to look for the goal. The goal is to explain the disadvantage of relying on audio features to predict a song's popularity. And let's eliminate anything that doesn't match that goal. Many popular predicting algorithms are based on a song's audio features. That's just telling me what they're based on. I don't see a disadvantage there. Algorithms based on audio features may misidentify main features with varying acoustic traits, making such algorithms less reliable predictors. That is explaining a disadvantage. I'll keep it. Audio features describe acoustic traits such as pitch intervals, which may vary, whereas descriptive, this is giving me different explanations for audio features versus descriptive tags. I don't care about that. The MSD's descriptive tags are reliable predictors. Again, it doesn't tell me a disadvantage of relying on audio features. So pretty quickly, pretty easily, my answer is B. So we're about to do our hard math questions, but I just want to let you know real quick that there's actually a bonus video with 20 additional hard questions, 10 in English, 10 in math, that I'm making available to my Fancy Pants students. So go ahead and use the link in the description to join and become a member, or you can just click that little button that says join. But anyway, let's go ahead and get into the math. And remember to pause the video and try each of these on your own first. I go really quickly through these math questions. Looks like we've got a linear problem here. It's talking about a line. So what does it tell us about this line? Intersects the y-axis at point 0, -6. So it's giving us the y-intercept. And it passes through the point 2, 2. It's also saying the point 20w lies on the line. So what can we do here? I would go ahead and figure out what the equation is for this line. That should make things easy, right? So we know that it's y equals mx plus b, and then b is our y-intercept. They tell us our y-intercept is -6, so mx minus 6. And then we can plug in 0.22 to figure out what our slope is. So 2 equals m times 2 minus 6. That means that if we add 6 to both sides, we get that 8 equals 2m. So basically our slope is going to be 4 after we divide by 2. So m equals 4. So now we can revise our equation here. Instead of y equals mx minus 6, we can say y equals 4x minus 6. And then from here, we just have to plug in 20 for x, because we have 20w, right? So y equals 4 times 20 minus 6. 4 times 20 is 80. 80 minus 6 is 76, or 74, I should say. So my answer is 74. All right, we've got a function here. Looking at it, looks like it's a linear function, because we basically have y equals mx plus b. It's just the mx situation is a little bit weird, but it seems to be a linear function. Okay, what's it asking me? If a temperature increased by 9.10 kelvins, how much did the temperature increase in Fahrenheit? Well, let's think about this. So we could just plug in 9.10 for x here, but like I said, it's kind of weird looking, and I'm not super into that because it's asking about temperature increase, which should just be based on our slope, not our y-intercept. So first, I want to FOIL this out so that we don't have this weird looking linear equation, so that it actually looks like a normal linear equation and we actually know what our slope is. So basically, if we FOIL this out, we get f of x equals 9 over 5x minus 9 over 5 times 273.15 plus 32. And let me just separate here. Over here, we have our y-intercept, which I don't care about because a y-intercept in the context of a word problem is always going to be our starting point. So as far as the actual increase goes, the actual slope, we just have 9 over 5x. So to get our answer, all we have to do is 9 over 5 times 9.10. And just to be safe, I'll throw this into Desmos real quick. But basically we get 9 over 5 times 9.1, and that's 16.38, which is choice A. Looking at the answer choices here, we've got linear equations because all of these are going to be linear, as you should be able to tell. And really it's just asking us which equation is going to match up with the scenario. So we're trying to figure out, it looks like, what our y-intercept is going to be and also what our slope is going to be, since those are the two things that we see at play here. Let's start with slope because that should be pretty easy. We basically want rise over run. And here it says gasoline is $4 per gallon, $4 per gallon. And if we're talking about how many miles he should drive, instead of thinking about gallons, we need to think about miles. So the second sentence here says 25 miles per gallon of gasoline. So our slope should be 4 over 25. And we can get rid of A and B because of that. And if we're trying to reduce his weekly expenditure by $5 by driving a certain number of miles, if this is going to help us to determine the number of miles, because it does say M is miles, right? That should be equal to only 5, 5 being $5, because we're trying to figure out how many of those miles equals that $5. So that is actually choice D. Okay, so we've got a geometry question here, and this is asking about the volume of some sort of container. I do like to start with the main question so I kind of know what I'm focusing on, but let's take a look and see what this container is. It's a right cylindrical container. Okay, so basically it's like a soda can with a height that is 4 inches longer than the radius. So let's think about this. Volume of any regular cylindrical container is going to be basically the area of a circle times height. So it'd be pi r squared times height. And it says the height is 4 inches longer than the radius. So basically we just want to express that. So we could write it, and I'm not going to look at the answers yet. I'm going to change it so that it makes sense for me. If the height is 4 inches longer than the radius, it could be like volume equals pi r squared times, instead of height, we would have r plus 4, right? Because we're going to take our radius, we're going to add 4 to it to get our height. So I'm looking for that answer more or less. And none of my answers actually look like this. So let's unpack it and actually distribute what's in parentheses. So we would get r squared times r is pi r to the third. And then if we multiply by 4, it'd be plus 4 pi r squared. So again, I'm taking this and I'm distributing it to what's in parentheses here. And then that actually lines up with answer D. So my answer is D. All right. It's looking from the wording like we have a system of equations here. And the reason I'm saying system of equations is we have two different types of something. Whenever you see two different types of something, that's usually a pretty big indicator that you're dealing with systems of equations. More specifically, if you have two types of something with different values. So in this case, tickets with values of either 12 or 8. And then you have another total, which is like the total number of items, right? So we have total number of tickets plus the total price. That indicator that we're dealing with systems of equations. Anyway, let's set this up. So I'm going to say x plus y, that is kid tickets and adult tickets, equals total tickets, which is 30. And then for price, I'm going to have 12x price plus 8y equals 300, because it says we have $300 in total. And then how much in dollars was spent on adult tickets? So from here, you could definitely use substitution or elimination. I would prefer to just throw it into Desmos at this point. So I'm going to open up Desmos real quick and plug in my two equations, x plus y equals 30 and 12x plus 8y equals 300. Looks like I'm going to need to zoom out, so I'll zoom out, and then my intersect is going to give me my x and y values, x being adult and y being kid. Looks like they're the same. So regardless, my answer is going to be 15. We just have to be careful, though, because it's not asking us how many adult tickets were sold. It's asking us how much in dollars was spent on adult tickets. So if we know that there were 15 adult tickets, but each adult ticket is $12, then it would actually be 15 times 12, which would be 150 plus 30. So it would be 180 as my answer. All right, we've got systems of equations here, and from the answer choices, it looks like some pretty complicated systems of equations, right? Usually when you see radical signs, it's an indication that you're going to have to end up using the quadratic equation, but I would rather just solve this using Desmos. So I'm going to pull up Desmos. I'm going to put both equations into Desmos as my first step here. So x minus y equals 1, and then we had x plus y equals x squared minus 3. So let's take a look at our solutions here. We've got 2.732, 1.732, or negative 0.732, negative 1.732. But more importantly, we need to match these up with actual answers. So let me squeeze this down a bit to give us some room here so we can see. Our first answer, we have 1 plus the square root of 3 and the square root of 3. So if I just know what the square root of 3 is in decimal form, that should help. SQRT is a little shortcut, by the way. Square root of 3 is 1.732. That's familiar, right? That was our intercept over here, 1.732. So that would match up. Now we just have to make sure that the x value matches up. Well, if we add 1 to it, 1 plus the square root of 3, that would indeed be 2.732. So we got lucky. Our answer is going to be choice A. But if that didn't work, we would just go down the line testing our answers till we find one that works. Next question is looking like we have a quadratic. This is factored form of a quadratic, right? And it's saying, which of the following intervals contains the x-coordinate of the vertex of the graph f? Now, from factored form, if it's asking about the x-coordinate of the vertex, there's actually a couple of cool tricks. If it were in standard form, that would be negative b over 2a. But since we're in factored form, it's actually just the average of the intercepts. So if we have x plus 3 and x plus 1, that means x equals negative 3 and x equals negative 1. Average of those two would be negative 3 minus 1 over 2, which is negative 2. So the x-coordinate of our vertex is negative 2. That means that the x-coordinate is going to be greater than negative 3, so not A. It's going to be greater than negative 3 and less than 1. That's true. And then the other ones, they're not negative, so our answer is B. This question is something I like to refer to as just like interpreting a quadratic equation, because it gives us a quadratic equation, right? And then it's asking us what A represents. Well, what the heck is A? It says the graph intersects the x-axis at 0 and A. So basically we know that A is going to be the bigger x-intercept, And there's somebody doing something in the yard outside. Sorry if you guys can hear that. I'll try to cut it out with my magic editing skills. But anyway, well, let's think about what an x-intercept is. So visually, we do have an upside down parabola because it's A is negative here. So if we have something like this, then our x-intercepts are both going to be when the price is $0, right? $0, $0. So at some point, it seems like if we sell too many products, instead of making a profit, we're actually going to make $0. So I'm looking for something about selling too many products, making $0. That's what A would represent. So choice A, the revenue when the unit price of the product is 0. So it shouldn't be that the price is 0, because remember, X is the price, and we can see that X is not 0, Y is 0, so A is not going to work. B, the unit price of the product that will result in maximum revenue. No, I would say $0 in revenue is not maximum revenue. That would actually be up here. That would be our vertex. C, the unit price in dollars of the product that will result in a revenue of 0. Yes, this will result in a revenue of 0, and just like this will result in a revenue of 0. And sorry, to be clear, I think a second ago I said that X is how many we're selling. It's not how many we're selling, it's the unit price. So basically, if we price it too low, we're not making any money. And if we price it too high, we're not making any money. But yeah, C would work. So C is going to be our answer here. We've got a measures of central tendency question here. I know because I see different measures of central tendency in the answer choices. And it's asking which of the following measures does not have the same value in both original and new data sets. All right, so let's take a look at what's happening and see if we can figure this out. It says we've got a data set of 27 numbers that has a mean of 33 and a median of 33. So this is telling me basically that these numbers are split up evenly. If you have the same median as you have mean, it means there's the same distance on average between the values. A new data set is created by adding 7 to each number from in the original data set that is greater than the median, and subtracting 7 from each number in the original data set that is less than the median. Let's demonstrate this by using a really small data set. Let's pretend that we have, we'll say 8, 9, 10. So the mean of this is going to be 9, and the median of this is going to be 9 because they're spaced evenly. We have 1 between each number. That's the rule that I was just mentioning. Now it's saying we're going to subtract 7 from each number less than the median and add 7 to each number over the median. So if we did that, our new data set would be 1, 9, and 17, right? Because they're still evenly spaced, because there's now 8 between them, the mean and the median are still going to be 9. So we know that those things would not be affected. So mean and median stays the same. The sum of the numbers is also going to stay the same because we subtract 8 and we add 8, that cancels out. So by process of elimination, it's going to have to be the standard deviation. And indeed, in a nutshell, standard deviation is basically like, on average, how far away from the mean are all of the numbers. We've got a percentage question here. It says percent increase. So I'm going to be using my percent change formula. And it says the manager estimated the percent increase from 2012 to 2013 would double. So basically this percentage increase that we can see here would double the increase from 2013 to 2014, which would be an increase that we can't see. How many subscriptions did the manager expect would be sold in 2014? All right, so let's start by finding the percentage increase here. So we'll use our percent change formula, which is the difference between the original and the new. Looking here, we can see that the difference would be 280 divided by the original number. The original number would be the first number, 5,600. We could get rid of a 0, get rid of a 0. If you know that 28 is half of 56, we basically have 0.5. But then we have to add the extra 0 because we have an extra 0 here, so it'd be 0.05. So that would be a 5% increase. And it says that that was double the percent increase that from 2013 to 2014. So then if we estimate that, we would have 2013, 5880. And now to increase half of 5%, so we would multiply by 1 for our original 100% plus 0.025. And that is something I don't want to do in my head, so I'm going to throw that into Desmos. 5880 times 1.025. And that is 6,027, which is choice B, which is our answer. All right, so this one I think is very tricky because it used to be that you could just read the last sentence for probability questions and kind of go from there. So if we read the last question, it says, if a person who preferred a picnic, so we know we're looking at this picnic zone, is selected at random, what's the probability that person responded by email, right? And hopefully if you look at the chart and you see that it's percentages, it'll kind of solidify that things are a little bit off. Like we don't have all the information we need just from the chart here, which is normally the case. So if we kind of skim through the passage, we see a really important detail that we need to know, which is for the survey, second to last sentence, for the survey, the number of email responses was twice the number of phone responses. So I like to just basically think, we'll say like phone had 100 responses, email had 200 responses. So basically the whole email side would get doubled. So our desired, instead of being 5, we're going to say is 10. And then our total would be the 10 plus the 20, which is 30. So then our probability is 10 out of 30 or 1 out of 3. Up next, we've got sort of a ratio question. It's asking us, to the nearest hundredth of a meter, what is the length of one edge of this sample? So we know we're looking for an edge. What are we looking at an edge of? The density of a certain type of wood is 353 kilograms per cubic meter. Okay, so we're looking at the edge of a cube, it seems. And let me just write that ratio down. It's 353 kilograms per cubic meter. We'll call that like m to the third. That's our ratio. A sample of this type of wood is the shape of a cube and has a mass of 345 kilograms. So we have a sample that is 345 kilograms. Let's first figure out how many, because this is 1 over here. Let's figure out how many cubic meters we have in the sample. So we'll cross multiply. 345 times 1 is 345. Then basically 353x. So we will divide both sides by 353. And I'll pull up Desmos to make my life easier here. So again, those numbers were basically 345 divided by 353. So we have 0.977, which is basically 0.98, but we have to be careful because 0.98 is one of our answers. But remember, it's not asking us how many cubic meters we have. It's asking us the length of one edge of this sample. So we would actually need to cube root our answer here. So it'd be like the cube root of 0.98 is going to be what we're looking for, because a cube is basically length times width times height. So one edge would be either the length, the width, or the height. So then if we throw that into Desmos, basically we could just take what we already have and cube root it. And that was just CBRT, by the way. 345 divided by 353. Probably get rid of that. And now we see it's actually 0.99, which is choice B. So be really careful about wording because they will always have wrong answers that line up with missing a step, right? So this question here is going to be about evaluating statistical claims. It is saying which of the following statements must be true. And basically, we just want to kind of read through the scenario and then eliminate anything that might not be true. So here it says, to determine the mean number of children per household in a community, Tabitha surveyed 20 families at a playground. For the 20 families surveyed, the mean number of children per household was 2.4. All right, so we have our full understanding here, right? Choice A, the mean number of children per household in the community is 2.4. That's not going to work because whenever we take a sample, it does not mean that we get the actual statistics on the population that we're sampling. We would never be able to say is. Furthermore, 20 families is a really small sample size, and it's also only families at a playground. So big issue there with saying in the community. It would have to be something more like who go to the playground in the community, and probably just a bigger sample size than 20 families. B, a determination about the mean number of children per household in the community should not be made because the sample size is too small. So in general, 20 is a very small sample size, like I just mentioned. That said, we don't know how many people are in the community. So that one, I don't think has to be true because it says must be true. It might be true. I think it's true. But because we don't know how many people are in the community, we can't really determine if it's too small. So we'll get rid of B. C, the sampling method is flawed and may produce a biased estimate of the mean number of children per household. Yeah, that's what I was saying when I said they're only serving families at a playground. It's not random. So C is definitely going to work, and that's going to be my answer. But if we wanted to be safe, we get rid of D. D, the sampling method is not flawed. No, we know it is flawed, right? So our answer is choice C here. All right, we got a SOHCAHTOA question here. It's asking about sine of x. So in SOHCAHTOA is OH, that's opposite over hypotenuse. Opposite x is 16, divided by the hypotenuse, which is 23. So my answer is 16 over 23. All right, so we've got a circle graphing question here. And the way that it's written, I can tell that we basically want to stick this into the normal version of the equation, which would be like x minus h squared plus y minus k squared equals r squared. And this isn't a huge deal. We basically just have to break this down, complete the square, so on and so forth. But it's going to take a minute. So I would probably just throw this into Desmos because I think it's going to be a little bit faster. So if we pull up Desmos, we'll throw it in. It was 2x squared minus 6x plus 2y squared plus 2y equals 45. We're trying to find the radius. So basically, we find the difference between the top and the bottom. That's going to give us our diameter. So we have y is 4.5. Y is negative 5.5. So the difference between those would be 4.5 minus negative 5.5. So basically 10. Half of 10 is 5. My radius is 5. My answer is 5. See how that's a lot faster? Power of Desmos, baby. I'm actually pretty curious how you did, so let me know in the comments below if you were able to get most of those questions right, or if there are certain question types that you still need to work on. And if you're looking to get some more study practice in, YouTube thinks that this video here is going to be the best recommendation for you, so go ahead and check it out.